All right, we're going to look at our last section in Chapter 11, 11.8, and talk about what we call expected value. Expected value is the idea of thinking about different outcomes of a certain situation and the probability that that outcome is going to occur to combine those ideas and figure out what's expected to happen in the long run. And they use this idea, for example, when they decide insurance premiums, or in Vegas, when you gamble a lot, what's kind of expected to happen in the long run, okay? Well, you're going to lose, right? Or else there would be no such thing as Vegas. But we're going to kind of talk about that idea in this section. So think about the question, would you be willing to spend $50 a year for an insurance policy that would pay you $200,000 if you became too ill to continue going to school? So $50 kind of sounds like a lot, but if it's for the whole year, and if you happen to get sick and you can't continue going to school, they're going to give you $200,000. That's a lot of money, right? Maybe some of you would take me up on that offer and buy that insurance policy. Well, let's say 1 in 5,000 students ends up getting too sick to continue going to school. Then the probability would be 1 out of 5,000 that you're going to use this policy and get the $200,000. So if I was the insurance company, I'm expected to pay that $200,000 for every 1 in 5,000 students, right? I take the probability, I multiply it by how much I have to pay out, and that averages to about $40 per policy. So how do insurance companies make their money then if they're going to end up paying $40 per policy for every single one on average, right? The $200,000 divided up. Well, think about that. I charged $50 per policy. If I have to pay out $40 per policy, then aren't I making $10 per person that has this policy? And so if I can get 400,000 people to buy this insurance in case they get too sick to continue going to school, I've just made $4 million being this insurance agent. Maybe I should stop teaching and sell insurance, huh? Let's use that idea and how they kind of calculate that to calculate what we call expected value. Expected value is a mathematical way to use probabilities to determine what's expected in various situations over the long run. Like I said, insurance policies, weighing the risk versus benefits in business ideas, and indicating to a player in a game of chance what will happen if the game is played repeatedly, so in gambling, okay? The standard way to compute expected value is to multiply each possible outcome by its probability and then add these together. So we have to first think about all the different outcomes. We then have to figure out the probability of all of those different outcomes. We're going to multiply those two together, and we're going to do that for every single one, and then we're going to add up all of those values. That'll give us what we call our expected value. Now, I was going to do a few basic examples, but they don't really mean anything unless you kind of put context to it. So I'm actually going to go ahead and skip example number 1 and 2 and get to some of the good stuff. But the completed notes are on Canvas. If you'd like to look at those, practice those, and see if you got the same answer as me. But let's actually get to some examples with some application to them, okay? So look at example number 3 with me. It says here, an automobile insurance company has determined the probabilities for various claim amounts to the nearest $2,000 for drivers ages 16 through 21. And so this is the amount typically that a person claims in auto insurance, whether they got into a car accident or whether their car was stolen or broken into or whatever it may be. And then they calculated the probability that that will happen. And then part A says calculate the expected value and describe what it means in practical terms. So again, remember, expected value is you're going to take the outcomes, and so the outcome for this insurance company is the different amounts they have to pay, right? Sometimes they pay $0, sometimes they pay on average $2,000, $4,000, $6,000, and so on. Then we calculate the probability that you're going to pay that outcome. So there was a 70% chance that nobody was going to claim anything in their insurance. The insurance company was going to have to give $0. There's a 15% chance they're going to have to pay out $2,000, 8% chance for $4,000, a 1% chance that they're going to have to shell out $8,000 to you, and a 1% chance that they're going to have to shell out $10,000 for you. Okay? So they took the outcome and the probability. In order to figure out expected value, we're going to take these numbers, the outcome and the probability, and we're going to multiply them together. So we're going to multiply 0 times 0.7 and 2,000 times 0.15 and so on. Let's go ahead and do that first. So I got 0, 300, 320, 300, 80, and 100. Now that I've taken the outcome and multiplied it by the probability, I'm going to add all of those numbers together. I ended up getting $1,100. I hope you got the same number I did. So what that's saying is that this insurance company, on average, over the long run, is expected to pay about $1,100 per policy. Now, if you're part of the insurance company, maybe you're the owner of this insurance company, what should you then charge your clients so that you don't lose money and that you don't charge them so much that they don't come to your company? Well, that's what this number is, right? You're expected to pay out about $1,100 per person. So you better make sure that you at least charge them that amount so that you don't lose money. Now you've got to be careful. You probably want to charge them a little bit more so that you can make money for a living, right? But not too much that they go to a different insurance company. But that's what this means, the expected value, what you're expected to get out on average over the long run, $1,100 per person. Okay, let's do another one. Most of you guys have taken standardized testing, whether that be the AIMS back in the day or SATs, ACTs. And so for the SATs, it's a multiple choice test. Each question has 5 possible answers, and you must obviously answer each of the questions in order to earn points. Now, 1 point is awarded for each correct response, and 1/4 of a point is actually subtracted if you get a wrong answer. No points are added or subtracted for answers left blank. And so what they've given is a chart that kind of talks about those different outcomes. So when you go to take the test, the SATs, what are the different outcomes when you answer the question? Well, you could obviously get the right answer, or you can get the wrong answer. So they've made a table of the different outcomes, okay? The question says here, find the expected point value of a random guess. So let's say you just guess as you're going through the SATs, what's expected to happen as you guess, and continue to guess. Is there anything to gain or lose on average by guessing? So let's see. Let's find our expected value by taking our different outcomes and multiplying it by the probability and then adding those values together. So our different outcomes are either guessing correctly or guessing incorrectly, right? No other choice. I guess leave it blank and then there's nothing, okay? So when you guess correctly, what do you gain or lose? Well, if you guess it correctly, don't you gain a point? A point is added to your score. And if there are 5 options for each question, it's a multiple choice test, then the probability that you're going to guess the correct answer would be 1 out of 5. There's 1 correct answer out of the 5 options. So the probability is 1/5. So if you don't guess correctly, your other outcome is guessing incorrectly. What do you gain or lose if you guess incorrectly? Well, unfortunately, on the SAT, they've organized it so that you actually lose 1/4 of a point. And so we need to mathematically show that we're going to lose 1/4 of a point by putting a minus or a negative in front of that value. What's the probability that you guess incorrectly? Well, again, if there's 5 options and one of them is the correct answer, how many of them are the incorrect answer? Well, that would be 4 out of 5, right? So now that we have the different outcomes, what we're going to gain or lose from each of those, and the probability of each of those, to calculate the expected value, we're going to multiply our gains times our probability, and then we're going to add them together. So here we go. Let's take 1 times 1/5. I got 1/5. And let's take -1/4 times 4/5, multiplying numerators with numerators and denominators with denominators. And then let's go ahead and add these guys together. Now, I'm adding fractions, correct? And remember, when we add fractions, we need a common denominator. So I'm going to make mine into common denominators, I can actually reduce that 4 over 20 into a negative 1/5. So then I have a common denominator, and I can add my 1/5 plus my negative 1/5. Uh-oh, what happens? Don't we end up just getting 0? So what the heck does this mean? Well, what this expected value means is that over the long run, if you take your SATs and you guess, and you guess, and you guess, what are you expected to gain or lose? Well, you're expected to gain or lose nothing on average. Okay? Now, obviously, if you guess correctly, you get a point. If you guess incorrectly, you get minus 1/4 of a point. But over the long run, if you guess, on average, you actually don't gain or lose anything. That's the expected value. Okay? Again, taking your outcomes, taking what you're going to gain or lose, and the probability that that's going to happen, multiplying those and adding together will give you your expected value. What's expected to happen on average in the long run?